Today we will discuss about continuity of a function of a complex variable. Before going to study about this, we have to know about continuity. What is meant by continuity? Continuity means continuous. That means without gap. For example, nowadays we are seeing in all the news channels, they are giving the information about coronavirus continuously. Without gap, they are giving the updates about coronavirus to give the awareness to the people. That is continuous in general. In maths, if the line is formed by joining all the points without a gap, it is called as a continuous. If the gap is arised here, then it becomes discontinuous. That means if the line is formed by joining all the points without a gap, it is called as a continuous or continuous line. Then what is meant by continuity of a function? To gain the definition, we have to consider a function first. So I considered here f of z as a function. Why I chose here z? See the heading. What they given? Continuity of a function of a complex variable. That means we have to gain the definition for continuity of a function by using the complex variable. That's why I chose z as a complex variable. Using that, I wrote f of z as a function. Then what is the difference between complex variable and function? See here, I chose z as a complex variable. Then we can write it in the complex variable form x plus iy. Here x and y are the variables, and also we can say x is the real part and y is the imaginary part. If you want to write down the function for this complex variable, we can write it in the form f of z. That means f of z is a function for the complex variable. But it should be write it in the form u plus iv. We can't write x and y. Why? We can write u as u of x comma y. That means we can write u as a ordered pair. Ordered pair means this is also one complex variable. Complex variable, one of the definition is ordered pair. Ordered pair also we can say the complex variable. We can write it in the complex variable form, ordered pair form, but we can't write x and y in the ordered pair form. That is the difference between function of z and a complex variable z. Then when the function will become continuous, if the following three conditions, then we can say f of z is a continuous. First condition is the function should be defined at some point in the continuous line. That means a function should be defined at some point. Here I choose that point as z0. That is first point. That means, see, f of z is defined at z0. F of z is defined at some point. I choose that point as z0. Next, second point is the limit of the function should be exist. That means limit should be exist for this function. That is second point. Limit should be exist for this function. Next, third point, if the limit of the function, see here, if the limit of the function must be equals to function of that point. What you choose point, that point must be equal to the limit of the function. Limit of the function must be equal to the function of that point z0. If it satisfies all these conditions, then we can say this function is continuous. This is the definition for continuity of a function. To solve the problems, no need to check all these 3 points. If you check only third point, it is enough. Why? Because in third point, we can see the above 2 points. See, limit of the function here also exists, and the function is defined at z0. This is also exist. This is first point, this is second point. So all the 2 points exist in the third point. That's why to solve the problems, we can check out the third point only. It is enough. Next, we shall move on to the problems. Show that if f of z equals z square plus 2z is continuous at 1 plus I. What we have to show here? The function is continuous. We have to show here. What is the given data? Write down the given data. F of z equals to z square plus 2z, and also given at 1 plus I. Then what it will become? Say, I said already the function, it is defined at z0. That means the function is defined at what? At z0. That's why I wrote z0 is 1 plus I. Then what we have to show here? The function should be continuous. The function we have to prove continuous. That's why we have to write down the formula or definition of continuous. Write down the third point of continuous definition. What's that? Limit of z tends to z0, f of z is equals to f of z0. Here all LHS is limit of z tends to z0, f of z, and RHS is f of z0. If you simplified and we get the same answer for LHS and RHS, then we can say the function is continuous. Check it out. Write down the LHS. LHS is limit of z tends to z0, f of z. Substitute all the given data, given values. What they given? Limit of z tends to z0. What they given? Z0 is 1 plus I. Write it here. And f of z. What's that? F of z? What they given? Z square plus 2z. Write down the f of z here. Then limit z tending to 1 plus I. That means we have to substitute 1 plus I in place of z. Substitute in the place of z. Then it will become 1 plus I whole square plus 2 into 1 plus I. Simplified it. That means a plus b whole square. It looks like a plus b whole square. That means a square plus b square plus 2ab. That means 1 square is 1 plus I square plus 2ab. 2 into I into 1 is 2i. Plus 2 into 1 2 plus 2 into I is 2i. Next 1 plus I square is minus 1. 2i to I is 4i plus 2. 2 plus 1, 3. 3 minus 1, 2. 2 plus 4i. I got LHS is 2 plus 4i. So apply the same procedure for RHS. That means, what is the RHS here? F of z0. Write down the f of z0. But here is z0, what they given? Z0 is 1 plus I they given. Write down the z0 value is 1 plus I. But it looks like how? It looks like f of z. What is f of z here? In the question, f of z is z square plus 2z. So write down f of z here, z square plus 2z. Substitute the z value here, 1 plus I. That means 1 plus I whole square plus 2 into 1 plus I. Simplify it. A plus b whole square, a square plus b square plus 2ab plus 2 plus 2i. I square here minus 1, 2i to I, 4i plus 2. What we got here? 2 plus 1, 3, 3 minus 1, 2 plus 4i. I got here same answer for LHS and RHS. So I can write the function is continuous. That means LHS is equals to RHS. Hence the given function is continuous at point what? At 1 plus I. Next we shall move on to the second problem. Show that f of z is equals to xy by x square plus y square. When z is not equals to 0, the value becomes 0 at z equals to 0 is not continuous at the origin. That means we have to show this function is not continuous at the origin. See, for this problem, what they given here, z is not equals to 0. That means z tending to 0. Like that problems, we have to choose a straight line equation. What is the straight line equation? Y equals to mx plus c. Here we have to choose c as constant or 0. Then the straight line becomes y equals to mx. So when the given z tending to 0, we have to consider a straight line. That means, see, z is not equals to 0 means z tending to 0 along the path y is equals to mx. That means when z tending to 0, we have to choose a straight line y is equals to mx. And all we know about that z tending to 0 means what? X plus iy tending to 0. That means x tending to 0 and y tending to 0. While we are not applying here y is equals to mx. But when we are applying the value of y, then we have to remove y tending to 0 in the problem. Why? Because y having some value. We can't write it is 0 or it tending to 0. That's why while applying the value of y, then we have to remove the y tending to 0 in the problems. That means z tending to 0 means x plus iy tending to 0. See, here substitute the y value, x plus I into mx tending to 0. Here I wrote only x tending to 0. Why? Because I substituted here y equals to mx. Substitute all these in the problem with the limit. That means apply the limit for the function. Limit of z tending to 0 f of z is equals to limit of x tending to 0 y tending to 0 x f of z. Substitute the f of z value what they given in the problem. When z tending to 0, the value of the function is xy by x square plus y square. So write down the f of z as xy by x square plus y square. See, I wrote here x tending to 0, y tending to 0 also. Both I wrote here. Why? Because I am not applying the value of y here. That's why I wrote y tending to 0. But in the next step, I removed y tending to 0. Why? Because I substituted here y is equal to mx. So substitute y value mx here. That is second step. Next, simplify it. In the numerator, we can write m into x square divided by, here you take the common factor x square, remaining 1 plus m square. X square cancel. What we will get the answer? M by 1 plus m square. That means while applying the limit, we are getting the value in terms of m. That means the limit depending on the value of m. Right? That's I wrote. See, the value of the limit depends on m, which is not unique for different values of m. That means when we substituting the different values of m, we can't expect the same answer here because it may be infinite values we can get. That's why it is not unique. That means we can't expect the same answer. See, that's why we can write limit does not exist here. See this point. Hence the limit does not exist here. Why? Because the what will say the limit definition? The limit, if we got the finite answer, then we can say limit exists. But here we can't getting the finite answer. We can't expect the same answer. We can't expect the finite values here. That's why we can say limit does not exist. If the limit does not exist, by the definition of continuity, we can say it is not a continuous. See here, limit should be exist in the continuity definition. So here limit does not existing. So we can say directly f of z is not continuous at z is equals to 0. Next problem, show that f of z is equals to x plus y whole square divided by x square plus y square when z is not equal to 0 and the value is 1 for z is equals to 0 is discontinuous at the origin. That means here also we have to show that the function is discontinuous at the origin. We can solve this problem like previous problem. That means apply the same procedure what you applied for previous problem. That means here also they given z is not equal to 0. That means when we are writing z tending to 0, we have to consider the straight line y is equals to mx. Here also apply the same procedure like previous problem. That means z tending to 0 implies x plus iy tending to 0. This implies x plus I mx tending to 0. Here also we have to write only x tending to 0 because we will apply y value after that. Substitute these in the problem with the limit. Apply the limit for the function. That means apply the limit for function. Limit z tending to 0 f of z is equals to limit of x tends to 0, y tends to 0, x plus y whole square by x square plus y square. This is the value of f of z they given in the problem. Then you remove the y tending to 0 here when applying the y value. So apply the y value and remove the y tends to 0. Simplify it. See, in the numerator, here take the x as common factor, remaining 1 plus m whole square. That means next step x square into 1 plus m whole square. Denominator take the x square common, remaining x square into 1 plus m square, write down as it is in the next step. So x square cancel, what we will get? 1 plus m whole square by 1 plus m square. Here also we are getting the value in terms of m, that means the value of the limit depends on m, which is not unique for different values of m. Hence the limit does not exist because we are not getting the finite value here. That's why the limit does not exist. So we can say f of z is not continuous at the origin. So last problem is show that f of z is x cube into 1 plus I minus y cube into 1 minus I divided by x square plus y square when z is not equals to 0. Then the value is 0 for z is equals to 0 is continuous at the origin. Here what we have to show, this function is continuous at the origin we have to show. See, this is different than previous problems. Why? Because here also they given z is not equals to 0. But we can't apply the previous methods. Why? See, in the problem they given in terms of I. So we can't use the previous methods. So you go through different method. That means you consider the first function as it is, you consider. Next we have to solve function till we should get u and v separately. That means f of z we all know f of z equals to u plus iv. That means we should get u and v separately. Up to we have to simplify first. So you simplify f of z. That means substitute inside the bracket x cube. That means x cube plus I into x cube minus y cube minus into minus plus I y cube divided by, write down denominator as it is. Next we are getting here real part and imaginary part. So separate it. What is the real part here? X cube minus y cube is the real part plus I. Take it out common. So remaining I into x cube plus y cube divided by, write down the denominator as it is. X cube, x square plus y square. Next, see, here we can separate denominator here. That means x cube minus y cube by x square plus y square plus I into x cube plus y cube divided by x square plus y square. It looks like u plus iv. So we can extract the u value. What is the u value? X cube minus y cube by x square plus y square. And v value is what? Coefficient of I is imaginary part, that is v. V is x cube plus y cube by x square plus y square. I wrote u in terms of u of x comma y. Why? I already told we can write u as a complex variable in the ordered pair form. We can write it in a ordered pair form. That's why we can write u as u of x comma y and v as v of x comma y. Next, apply the limit for both u and v. If we got the same answer for this, we can say directly f of z tending to 0 for limit when we apply the limit. Let's see. Apply the limit first for u. So I wrote limit as x tending to 0, y tending to 0 instead of z tending to 0. Why? Because I wrote in u in terms of x and y coordinates. That's why instead of writing z tending to 0, I wrote x tending to 0, y tending to 0. Simplify it. Substitute the u value first. What is the u value here? X cube minus y cube by x square plus y square. So substitute here the u value first. Next, apply the limit x tending to 0, y tending to 0 we can choose anyone first. I choose here x tending to 0. I substituted first x tending to 0. That means x value becomes 0. What is the remaining? Minus y cube by y square. So y square cancel. I got minus y when x tending to 0 applying. Next, apply the limit y tending to 0. It becomes 0. Apply the same procedure for v. That means apply the limit for v as x tending to 0, y tending to 0 here also instead of z tending to 0. Because here also v we can express here coordinates x and y. That's why we have to write x tending to 0, y tending to 0. So apply the value of v here. Next, apply the x tending to 0 limit. That means we got y cube by y square is going to cancel. What I got y if x tending to 0. Next, apply the y tending to 0 limit. We got here 0. That means when applying the limit for u and v, we got same answer. Or here, if you apply the limit for u, we got 0. Apply the if we applied for v, here also we got 0. That means u plus iv tending to 0 when apply the limit. So we can write the function is 0, f of the function f of z tending to 0 when the apply the limit for f of z also. So I wrote limit z tends to 0, f of z is equals to 0 because f of z is equals to u plus iv. We are getting u plus iv tending to 0 if the limit is applying. So we can write. Why I wrote this one? Because we have to show here the function is continuous. That means we have to check the third point of continuity definition. So I am writing the continuity definition, or I am checking the continuity definition limit z tends to 0 f of z and also f of z naught. See, first condition is satisfied. LHS is satisfied. RHS of continuity function what? F of z naught. We have to check here. F of z naught means z naught what they given in the problem. See, they given 0. So f of z naught means 0. Write down the z naught value 0. Then it becomes f of 0. What we got here answer? They given already when z tends to 0, the value becomes 0. So we can write directly it is 0. So third condition of continuity function satisfied. LHS and RHS are equal. So we can say by the definition of continuity function f of z is continuous at z is equals to 0.